Welcome back. In the last lecture, we talked about permutations and combinations. Permutations were situations where the order matters. And examples of these were license plates, passwords, rearranging people in a line for a photograph, picking people for special jobs. For example, picking people for president, vice president, secretary. For permutations, the way you deal with permutations is you first figure out how many blanks you need. And then for each blank, you count how many options you have for each blank. And that's how you deal with permutations. Combinations are situations where the order does not matter. A common example of this was picking a team of 5 people, where you don't have different jobs for special jobs for the 5 people. You're just picking a team of 5 people. And for combinations, the final answer is going to be something, choose something. The total number of items you have to choose from, and then how many you're choosing. Today, I'm going to add 2 new situations. The first one is called permutations with lookalikes. Situation here is how many different ways can you rearrange the letters of the word Mississippi. So we're talking about rearrangement. So if I swap, say, the M and the I get something different. So the order here does matter, which is why it's called a permutation. Now, the difference between this permutation and a regular permutation is that we have things that look alike here. Okay, notice that I have I's that are repeated. I have 1, 2, 3, 4 I's. I have S's that are repeated, and I have P's here that are repeated. Now, even though if I swap the M and the I, that counts as 2 different things because it looks different, right? But because I have lookalikes, if I swap 2 of the lookalikes, for example, if I swap the 2 S's, I don't get anything new, right? It looks exactly the same. If I take the 2 S's and swap them, you don't get anything new. So we have to take into account those situations. The way you deal with permutations with lookalikes is you start off the same way as a regular permutation. So figure out how many blanks you need. So here I'm rearranging the letters of the word Mississippi, which means I should end up with the same number of characters total. So let's count how many characters are in Mississippi. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11 letters total. I should have 11 blanks. Okay. For each blank, count how many options you have. For the first blank, I should have all of the characters as an option. So there's 11 of them. And then I'm rearranging, so whatever character I picked for the first blank, I'm not going to use again, which means for the second blank, I should be down to 10. And then for the same reason, I should be down to 9, 8, 7, 6, 5, 4, 3, 2, 1. Now, if this were a regular permutation, you would be done. But because we have lookalikes, I now have to divide by the lookalikes, okay? So look for the letters that are repeated. So what's repeated? I have I's that are repeated, okay? Count how many I's you have. 1, 2, 3, 4. Okay, so I have 4 I's that are repeated. You're going to divide by 4 factorial. And that's for the 4 I's. What else is repeated? I have S's that are repeated, so count how many S's you have. 1, 2, 3, 4. 4 S's, so another 4 factorial. And that's for the 4 S's. What else is repeated? I have P's that are repeated, so there's 2 of them. Another 2 factorial. And that's for the 2 P's. And that's it. That's how you deal with permutations with lookalikes. So on your lab, you can just enter your answer in just like this. So a fraction on top, 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 over 4 factorial, so 4 exclamation mark times 4 exclamation mark times 4 exclamation mark. So You can leave it like that. Now, if you wanted a final answer, let me show you how to enter it into a calculator to get a final answer. So the calculator that I'm recommending you use is called a Desmos Scientific Calculator. You can either Google Desmos Scientific Calculator, or I put a link at the beginning of each question on the lab. So it's a fraction. I'm going to click on the fraction button, which is all the way on the right, the a over b. Okay, up top, it's going to be 11 times 10. 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Okay. Up top. On the bottom, 4 factorial times 4 factorial times 2 factorial. So on the bottom, 4 exclamation mark times 4 exclamation mark times 2 exclamation mark. And that's your final answer, 34,650. So you don't have to find a final answer. You could if you want, but you can also leave it as this big fraction. All right. The next new situation we'll talk about is called I'm going to call multi-choose. Example here is I need to pack a bag for a business trip. My closet contains 13 shirts, 10 pants, and 15 ties. I would like to bring 4 shirts, 4 pants, and 6 ties. How many ways can I pack for my trip? So how would I pick these items to pack? I'm going to first pick my shirts, right? I'm going to pick my 4 shirts. Does the order matter when I pick these 4 shirts? No, it doesn't, because I'm going to pick the 4 shirts and then I'm just going to throw it into the suitcase. So it doesn't matter which shirt I pick first, which one I pick second and third and fourth. So this is similar to a combination, but the difference is a regular combination, you're just choosing one time, right? You're choosing several items just one time. Here, I have to choose multiple times. I have to choose some shirts and then choose some pants and then choose some ties. So this is going to be multiple combinations. So how would I do this? I would first pick my shirts. I have 13 shirts total, and I'm picking 4 of them. So this is going to be 13 choose 4. That takes care of my shirts. And then I'm going to choose my pants. I have 15 pants. I have 10 pants total. And then I'm choosing 4. That's going to be 10 choose 4. And then my ties, I have 15 ties total. I'm choosing 6. That's going to be 15 choose 6. So multi-choose, you're choosing a couple items, and then you're choosing a couple more items, and then you're choosing a couple more items. And in each of these choosings, the order that you're choosing, the order that you're picking the items does not matter. And then from here, you're going to go to your calculator and calculate each of these combinations separately. So go back to my Desmos Scientific Calculator. To enter combinations into the calculator, you're going to first click on FUNC, function. That should bring up this menu, and then click on the NCR at the bottom. And then you type in the total, comma, how many you're choosing. So for the first one, 13 choose 4 is going to be 13 comma 4. That's 715. The second combination, 10 choose 4. So another, click on NCR again, 10 comma 4. That's 210. For the last one, 15 choose 6. Click on NCR again. That's going to be 15 comma 6. 5005. And the way you're going to enter this into your into the lab is 715 times 210 times 5005. If you want to, you can also multiply that out and get a final, single final answer. All right, let's try some examples. The hard part about the examples in this section is that the first thing you need to do is decide which of these 4 situations you're in. Is it a regular permutation, regular combination, permutation with lookalikes, or is it a multi-choose? Example 1. You have a book collection containing 29 books. You want to give away 11 books to your cousin. How many ways can you pick the 11 books to give away? The first thing I would ask myself is, when you're picking these 11 books, does the order matter? Does it matter which book you pick first, which one you pick second, which one you pick third, and so on? Probably not, right? You're picking 11 books, you're probably putting it in a box and then just giving it to your cousin. So it doesn't matter which book you pick first. So if it doesn't matter, if the order does not matter, it's going to be one of the combinations, either a regular combination or a multi-combination or multi-choose. And the question is, are you choosing a couple things and then choosing a couple more things and then choosing a couple more things, or are you just choosing one time? For this one, you're just choosing one time. You're just choosing 11 books and then you're done. So this is going to be a regular combination. Which means that final answer is going to be something, choose something. Okay. How many books total? 29. And then how many are you choosing? 11. Go to your calculator. The way you enter combination is click on FUNC, function, and then click on NCR. And then you're going to type in the total, comma, how many you're choosing. So 29, comma, 11. Big number. 34597 290. 34,597,290 ways you can pick the 11 books to give your cousin. All right, example 2. Credit cards and debit cards often require a PIN number consisting of 4 digits. So right off the bat, PIN number is similar to a password, similar to license plates. So definitely the order is going to matter here. Okay, and now the question is, the two situations where the order does matter is permutations, regular permutations, or permutations with lookalikes. Now, the advice I have here is that the only situation where it's a permutation with lookalikes is pretty much this situation here, where you're rearranging a word. In this example, we're not rearranging a word, right? We're creating a PIN number, creating a password. This one's going to be a regular permutation. Which means I need to first figure out how many blanks I need. So I want a PIN number that has 4 digits. So 1, 2, 3, 4. Okay, these are going to be digits. And then what else do I want? Sam wants to create a PIN number that starts with 743. Okay, so this first one needs to be 743. So let's go ahead and fill out the first blank. First blank, I need to be 743. How many options do I have? Just 3, right? 1, 2, 3. Now, for the rest, I need to also keep in mind whether repetitions are allowed or repetitions are not allowed. It does say here that repetitions are allowed. Which means for the other blanks, I can use the full number of options for digits. So digits are 0 through 9. So 0 through 9, there's 10 options there. Okay, because I'm allowed to repeat, I should have the full number of options there. So that's 10 for the same reason, 10 for the same reason, 10. So enter 3 times 10 times 10 times 10. Example 3. License plates in a certain state follow the format 4 letters followed by 4 digits. Right off the bat, license plates is one that we've seen multiple times. This is a regular permutation. Okay, first figure out how many blanks you need. 4 letters. Letter, 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 letter. Followed by 3 digits. And what else is important here? Letters D, O, and Q are not allowed. Okay. And then repetitions are not allowed. So repetitions are not allowed. Okay, letters. How many options do I have? So normally letters will be A through Z, which is 26. In this example, I'm giving you a restriction that you're not allowed to use these 3 letters, which now, what's the total number of options I have? A through Z is 26. If I remove 3, so 26 minus 3 is 23. So I have 23 options for letter. Now, because I'm not allowed to repeat, whatever letter I chose for the first blank, I can't use again, which means I don't have the full 23 anymore. I'm down to 22. And then for the same reason, I'm down to 21, and then I'm down to 20. Digits, 0 through 9, that's 10. And then because I'm not allowed to repeat, okay, for the next digit, I do have to reduce it by 1. So I need to reduce it by 1 to 9. And then I need to reduce again to 8. Example 4. Miguel would like to create a password by rearranging his phone number, 916-555-1167. How many different passwords can he create? Passwords, order does matter, so this is either a regular permutation or a permutation with lookalikes. So the way it's written here, you're rearranging this quote-unquote word, but the word here just has numbers instead of letters. So this is definitely a permutation with lookalikes, because we definitely have repeated characters there. So this is a permutation with lookalikes. And the way you deal with permutations with lookalikes is first start off by figuring out how many blanks you need. We're rearranging this phone number, so I should end up with the same number of numbers or digits. Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so I should have 10 blanks total. For the first blank, how many options do I have? So how many characters here, or how many digits here? There's 10 of them. And then I'm rearranging, so whatever digit I pick for the first blank, I'm not going to use again, which means I'm down to 9. And then 8, 7, 6, 5, 4, 3, 2, 1. Now, I do have lookalikes here, right? Because I do see a 5 that's repeated 3 times. I think a 1 that repeats, and then maybe some other ones. So I do need to divide by the lookalikes. So what's repeated? I think the 1's repeated. So how many 1's are there? There's 1, 2, 3. So there's 3 1's, which means I need to divide by 3 factorial. And that was for the 3 1's. What else is repeated? I see 5's. So 1, 2, 3. I think there's 5 3's, or 3 5's, sorry. 3 5's, so I need to divide by 3 factorial. And that's for 3 5's. And then do I have anything else that's repeated? I think I have a 6 that's repeated twice. Okay, so for that 6, it's repeated 2 times, so I need a 2 factorial. And that's for the 2 6's. Okay, so be careful here. The 6 is repeated, but you don't divide by 6 factorial. You divide by how many of the 6's you have. So there's 2 factorial because there's 2 6's, 3 factorial because there's 3 5's. And you're not dividing by 5 factorial. You're dividing by 3 factorial because the 5 appears 3 times. Example 5. 14 students from Cosumnes River College and 18 students from Yuba College attend a new student orientation. At the end of the event, 8 students will be chosen to receive $20 gift certificates to Jamba Juice. Part A, how many ways can the 8 students be selected? Okay, so you're choosing 8 students. First thing I would probably ask myself is, does the order matter when you're choosing these 8 students? They're all receiving $20 gift certificates. So it doesn't really matter who gets picked first or second or third, because they're all getting the same prize. Order does not matter. Okay. Question is it a regular combination or is it a multi-choose? Part A, I'm just choosing 8 students. I'm just choosing one time. Regular combination. How many students total do I have to choose from? There's 14 students from CRC, 18 students from UBA, for a total of, what's 14 plus 18? So 32 students total. And I'm choosing 8. All right, let's go to your calculator. Click on FUNC. Click on NCR. The total, which is 32, comma, how many you're choosing? 8. All right, big number, 105, 18, 300. That's 10,518,300. Part B. How many ways can 8 students be selected so that all 8 are from Yuba College students? Oh, from Yuba College. So the only difference here is that part A, okay, I want 8 students, but no specification. So you're choosing 8 from everybody, which is 32. If I want just Yuba College students, I'm just going to choose 8, but from the 18 Yuba College students. So for part B, if I want all Yuba College students, I'm just going to choose from the group from Yuba, which means 18. So 18, choose 8. Okay, so I'm only choosing 8, but I'm focusing on just the Yuba College students. So the total is now 18, and I'm choosing 8 from that 18. NCR, total, 18, comma, 8. 43,758. Part C. How many ways can 8 students be selected so that there are exactly 3 Cosumnes River College students? Okay, so this one is a tricky one, but look for the keyword exactly 3. So I want exactly 3 from CRC. What does that mean? That means I want 3 from CRC and the rest from Yuba, right? So exactly 3 from CRC means I want 3 CRC and then the rest from Yuba. How many is the rest? I want 8 students total, so 3 from CRC, the rest from Yuba, which means 5 from Yuba, right? Because I want 8 students total. So really, when I say exactly 3 students from CRC, I mean 3 from CRC, 5 from Yuba. So what you're doing here is you're choosing 3 from CRC and then 5 from Yuba. So this part C is really a multi-choose, right? Because I'm choosing a couple and then I'm choosing some more. This is a multi-choose. Okay, for the CRC, I'm going to choose 3 students from the CRC group, which is, there's 14 CRC. So this is going to be 14 choose 3. And then I'm going to choose 5 from the Yuba group. Yuba, there's 18 students. So this is going to be 18 choose 5. Do each of these combinations. So NCR. First one, 14 comma 3. 364. The second one, NCR again, 18 comma 5. 8568. Okay, and then your final answer is going to be 364 times 8568. Example 6. The math club at CRC is organizing a fundraising event. The club, which has a total of 18 members, needs to form groups for various tasks. There needs to be a group of 3 people to sell tickets, a group of 5 people to help set up for the event, and a group of 4 people to help clean up after the event. How many ways can these groups be formed? Think about how you would pick these people. Wouldn't you just pick 3 people, and then pick 5 people, and then pick 4 people? This sounds like a multi-choose. And even more, when you're picking these 3 people to sell tickets, does it matter who gets picked first, second, or third to sell tickets? No, it doesn't, right? They all have the same job, so you're just picking a team of 3 people to sell tickets, a team of 5 people to help set up, and then a team of 4 people. So this is really a multi-choose. Okay, so first thing we need to do is pick the 3 people to sell tickets. So you're choosing 3 people from a total of how many? There's 18 members total, so from a total of 18. And then you're picking the 5 people to help set up from a total of how many? So here you have to be careful, right? We don't actually have the 18 total anymore because we already picked 3 people to sell tickets. So how many people do we have left? 18 minus 3. That's 15. Okay, so we picked 3 people already to sell tickets, so we don't have the full 18 anymore. We have 15 people left, and then from the people left, we're picking 5 people to help set up. And then you're going to pick the 4 people to help clean up. And then for the same reason, how many people total that are left? So when we were picking the 5 people to help set up, right, there was 15 people left. We chose 5 of them to set up. How many people are left? So 15 minus the 5, there's 10 people left. Okay, now go to your calculator and do each of these combinations. All right, click on FUNC function, click on NCR, 18 choose 3, that's going to be NCR 18 comma 3, 816. Next, 15 choose 5, NCR again, 15 comma 5, 3003. 10 choose 4, NCR, 10 comma 4, 210. Okay, the way you're going to enter this is 816 times 3003 times 210. All right, so one thing I want to point out, okay, this is like the third multi-choose we've done so far. Right, why was it that here we had to reduce, whereas we didn't talk about this on the other 2 examples? So in the other 2 examples, so in our previous example, where we were talking about the CRC students and the Yuba College students, we chose 3 CRC students, and then we chose 5 Yuba College students. So we didn't have to do any reduction here because we're first choosing CRC students, right, from the CRC group. And then for the next choosing, we're actually choosing from a different group, right? We're choosing from the 18 Yuba College students. So you're choosing, and then you're choosing from a different group. Even in our example that we did on the first page, where I was choosing shirts, pants, and ties, right? I'm choosing pants, or I'm choosing shirts, which is one group, and then I'm choosing 4 pants, but that's from a different group. And then I'm choosing ties from a different group. So those 2 examples that we talked about prior to this one, it was a multi-choose, but in each choosing, we were choosing from a different group or category. This one, right, there's only one group. There's the 18 members total group. So here, we're actually choosing from the 18, and then we're choosing from the same group again, and then we're choosing from the same group again. So when that happens, you do have to reduce. Next up, example 7. The tune Twinkle Twinkle Little Star has 7 notes in its first line. C, C, G, G, A, A, G. Assume that all 7 notes are held for the same length of time. If the notes are rearranged at random, how many different melodies could be composed? Okay, so we're talking about music here, so it does matter what note you play first and what note you play second. So this is definitely a permutation. I do see some letters repeated. So this is going to be a permutation with lookalikes. All right, so first figure out how many blanks you need. So just count 1, 2, 3, 4, 5, 6, 7. So this is just a rearrangement of C, C, G, G, A, A, G. So it's a rearrangement of a word. Okay. All right, so for the first blank, how many options do we have? I think we counted 1, 2, 3, 4, 5, 6, 7. So we have 7 options. And then we're rearranging, so whatever I picked for the first one, I can't use again. So I'm down to 6. And then 5, 4, 3, 2, 1. And then because we do have lookalikes here, I do have to divide by the lookalikes. Okay, so what's repeated? The C is repeated. I see a C that appears 2 times. Okay, so I need a 2 factorial. Okay, that's for the 2 C's. What else is repeated? The G appears 1, 2, 3 times. So I need a 3 factorial. That's for the 3 G's. And then the A also repeats, and it repeats 2 times. So I need a 2 factorial for the 2 A's. Example 8. A family consisting of 4 children, 10 adults, have reserved a row of seats at a theater. The 4 children need to sit in the middle with 5 adults on either side. How many ways can the family seat themselves? So this is a rearrangement of people in a line for a photograph, but in this case it's for seating at a theater. So rearrangement of people in a line, it's going to be a permutation. We're talking about people here, so you can't really have lookalikes. So this is definitely just a regular permutation. Okay, figure out how many blanks you need. I have 4 children in the middle. So I put those in first. These are children, 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 children. And then I need 5 adults on either side. Okay, 4 children in the middle, 5 adults on either side. Let me take care of the children first. How many options do I have for children? There's 4 children total, so I have 4 options. We're talking about people here, so it's understood that you're not allowed to repeat, right? Because I can't have the same person sit in the same place in two different places. So for the next child, I should be down to 3, and then down to 2, and then down to 1. Adults. Okay, for the first adult here, how many adults do I have total? I have 10 adults. Okay, first blank, I should have 10 options. And then for the same reason, we're talking about people here, so it's understood that no repetitions are allowed. For the next adult, I should be down to 9. And then 8, 7, 6, 5, 4, 3, 2, 1. Example 9. When ordering the largest family pack of Fire Wings, you can choose 10 different flavors. And here are the flavors. Part A. How many different ways can you order a family pack at Fire Wings? In other words, how many ways can you choose the 10 different flavors? Does it matter what order you choose the 10 flavors? Does it matter what you choose first, second, third, 10th? Probably not, right? So this is definitely going to be either a combination, regular combination, or a multi-choose. For part A here, you're just choosing the 10. So this is a regular combination. What choose what? We're definitely choosing 10 from a total of how many wing flavors? So let's count how many flavors are here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. 21 wing flavors total, and we're choosing 10. Okay, on my calculator, click on FUNC, NCR. 21 choose 10, it's going to be 21 comma 10. 352 716. Okay, next up, how many ways can you order a family pack at Fire Wings if you don't like any of the classic wing flavors? So in part A, we're choosing 10 from everything. Part B, I don't like the classic wing flavors, so I'm basically just going to choose 10 from these. Okay, so this is going to be another regular combination. And I'm choosing 10, but since I don't like the classic, I'm just going to choose from these options. So how many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So 14 choose 10. Okay, my calculator, NCR, 14 comma 10, 1001. Part C. How many ways can you order a family pack at Fire Wings if you want exactly 2 dry rub wing flavors? All right, so here, the key word I'm looking at here is exactly 2. This is going to be similar to the other example that we did with the CRC students and UBA students, where I asked how many different ways can you pick exactly, what was it, 3? Exactly 3 CRC students. So here, exactly 2 dry rub. And what that means is I want 2 dry rub and the rest not dry rub. All right, non-dry rub. Okay, so exactly 2 dry rub means I want 2 dry rub and then the rest not dry rub. So how many is the rest? How many flavors do I want total? I still want 10 flavors total, right? I want 2 dry rub. The rest is going to be 8, right? Because I want 10 total. So I want 2 dry rub and then 8 non-dry rub. So this is basically I want to choose 2 from the dry rub, and then I want to choose 8 from the non-dry rub. This is a multi-choose. Okay, so 2 from the dry rub. How many dry rubs do I have? 1, 2, 3, 4, 5, 6, 7. So 7 choose 2. That gives me my 2 dry rub, and then the rest, which is 8. I'm going to choose 8 from the non-dry rubs. So what is not dry rub? That's going to be the classics and the fusion. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So 14 non-dry rub. All right, now just do each of those combinations on your calculator. The first one, 7 choose 2, so NCR 7 comma 2. That's 21. 14 choose 8, NCR 14 comma 8. 3003. Okay, and then the way you enter it is 21 times 3003. Example 10. Ryu wants an identification number code consisting of 4 letters followed by 3 digits. So already this is like a password, so this is a permutation. We're not rearranging anything, so this is a regular permutation. How many blanks do I need? 4 letters, 3 digits. And then I want some more stuff. He wants the code to start with H, P, or I. Okay, so he wants HPI here. And end with 7, 9, 2, or 1. So ends with 7, 9, 2, or 1. Okay. Go through, count how many options you have for each blank. So if you have restrictions here, I want to start with the restricted blanks first. First blank, I want H, P, or I. That's 3 options. Last blank, 7, 9, 2, or 1. That's 4 options. And then now the letter. Now, I also need to pay attention to whether I'm allowed to repeat or not, right? Because if I'm not allowed to repeat, I have to remember to reduce. Okay, letters. The letter part can have repetitions. The digit part cannot have repetitions. Okay, so the letter part, I'm allowed repetitions, so I can use the full number of options. Letters A through Z, that's 26. I'm allowed to repeat, so I can use the full options, 26, 26. The digit part cannot have repetitions, okay? So for this digit, 0 to 9, normally that would be 10, but I have to keep in mind that I used 1 digit already, so I should be down to 9. And then for the same reason, down to 8. All right, so that's a wrap on our counting unit. Have a great day. Talk to you later.